Hey everyone, I hope you all doing fantastic. Welcome to a tutorial where we're gonna do like a pretty cool parametric pattern in Grasshopper, right? So it's gonna be quite a lot of important topics about computational design in Grasshopper, such as transformations and attractor. We even gonna have like image sampler here, and essentially the cool part about like this setup we are going to do is that it's really change like you can change it so easily and so quickly and just play and have so many extremely different results in one click, right? So and then like what you can do with this result with this pattern is really up to you. I mean, you can print it, you can use it for something more 3D, you can draw it with a robot. I mean, so, but this tutorial is really about like going into computational design, like Grasshopper, how to set up, right? This kind of stuff, and it's quite beginner friendly. Maybe that's not the first thing you would watch if you're like just starting, but it's I think it's a fairly good start if you just try to understand the most difficult topics. I think it's totally like manageable. Okay, should we go? And I will explain, right? Like we will construct these together and see how, like how do we create these parameters that we will manipulate later, right? And achieve like very different results. All right, um, let's go. I would say we start from like opening Rhino, opening Grasshopper, a new file completely, and for this for this tutorial you need two plugins. um, One is Lunchbox, and another is Kangaroo 2, which are like super standard plugins. So it's good to have them if you are doing like anything in this program, right? um, okay, just gonna okay, I don't have bifocus on this laptop. Anyway, it doesn't matter. Let's start from creating like a rectangle, right, where we're gonna base our pattern. So for that, we use a component called rectangle, and let's say I will create A4, A4, like this is in millimeters, right? It's 297 to 210. Okay, cool. Perfect. We call it rectangle. Just, well, this is something that you would do to keep everything organized and clear. And then we will transform it to surface. Simple move. It's actually not okay. It's the simplest move. Doesn't mean the best. All right. We have a surface. This is our first step. We group it and we call it creating surface. Perfecto. Okay. Then what we're gonna do is like, because we need the pattern, like we will divide this rectangle into a certain kind of like patterning thing, and we will use kind of like diamond panels is a component in Lunchbox. And if you don't like the aesthetics of well, these like diamonds, I don't know, like triangles, diamonds indeed. There are many others in Lunchbox that you can just like try and see what. Sorry, I have too much stuff. What works for you better? Yeah, hexagons, quad panels, whatever. It's just like one of the simplest way to show you how to pattern, kind of like, I wouldn't say an image, but more like using an image map to create very different results, right? Kind of like generative patterning, you would say. Okay, so we will create a number slider to control our divisions of panels, and we will call it panels U division, and then we will call panels V division. Yeah, so this is by, yeah, it's like essentially how do we divide it, right? I think it's pretty intuitive, I would say. Okay, what's important here is that we will merge both. By the way, it kind of gives me all of these surfaces, right, as an output. And we will combine all, and okay, you will see what we're gonna do, because essentially we just need like surfaces, right? And this is what we are doing here. Instead of having one big surface, right, we divide it into like smaller ones, and also shaping them in a way that we want. Okay, we call it panels. And what I also like to do is I like to group stuff that we are like stuff that if you change, you receive different results in a certain color. You can choose any color that you like. I mean, for me, it's gonna be, yeah, like a bit like this lavender. I don't know, whatever. Okay, let's group our second step, right? So far, I think it's very clear. Divide to panel, like there will be a little bit of more complex stuff, but more on the transformation side, and we will tap into that a bit later. Okay, and so then what is our next step? We need to divide these panels into points, right? Because essentially, if we are talking about drawing something with a robot, the robot needs what? Points into space, right? Where it like draws certain stuff, for example, right? And in general, like this tutorial is like for more point-based stuff. And if you print it, what's cool is that you can kind of have different points on top of each other and create a bit of like this layering options, which can be really interesting, graphically speaking. All right, we copy the last part, panels, and we essentially need to divide it into points. We will use divide surface, yes, and the amount of points, this is a little bit of like a very custom thing, and you can, like, if you feel like it, try something else. But what we're gonna do is that we just going to create a component called, yeah, like density points. Let's say from 2 to 10. Okay. Points. Right, and we will connect it to, like, we will connect it, yeah, to how large the area is, right? So because like the point is that we want like approximately the same amount of points, but some of the panels are smaller than others. So, and this is, again, I don't think it's like the best way to do it, to be honest, like, but there are just like so many multiple ways you could possibly link depending on what you want. Anyways, we will divide it into our parameter. Okay. All right. Be careful here, because this is how your numbers should look like, right? Why it's important? Because if we will connect some really weird numbers, your grasshopper can get stuck, right? Because of like intense calculations it has to do. So actually, it's a good time to save document. I mean, okay, let me find right, and you don't have to save Rhino, you just need to save Grasshopper. Yeah. All right, so what we need now. Yeah, I'm actually really doubting it's the best way to do it, but let's go with it first. Yeah. So this is how it looks like right now, kind of ish. Okay, it's very dense. Does it make any difference? Okay, it kind of does. Okay, maybe this is where you can say, I don't know, I want like from 8 to 20, and Control Shift, you take the, yeah, you take this stuff and place it here. Anyways, by the way, you can like also just put the number here, to be honest, like that's also fine. All right, cool. I'm gonna simplify it just because I hate these, you see, like data trees. It's like a bit messy. Okay, this looks much better. We will trim tree. If you don't understand the data tree part, this is not where I'm gonna explain it to you, to be honest, because it's just like this is a bottleneck of Grasshopper. If you get it, like you get the whole thing. Like if you don't, just, I mean, try through, you know, like playing with it, a bit trial and failure, and soon enough, like you're probably also gonna get it. Just because it's a matter of practice, to be honest. Okay, cool. But for now, just like follow, and we will get to certain results. Yeah. Okay. We will call this group divide panels. 2 points. All right. Nice. Okay. Now, interesting part. So Control A, preview off. So we have only the latest stuff here. Okay. Now what you're gonna do is you wanna actually implement image sampler here, yeah? And we need to, okay, for the image sampler, which is this, we need to, first we're gonna put black and white because we need like one, how to say, like one number, which would be like intensity from white to black. And we let me find something that is interesting enough. Okay, image maps. Let's go here. Okay, we will work with this one. It's something that I did in Photoshop in like 1 second. I think you can also use Paint, obviously. Okay, cool. Okay, so we have this beauty, but it does, like, it needs essentially like points, right? So it needs like the points that it will check, and it will be like, okay, you know, white, this is white, or like, you know, this is black, this is gray, right? So you need to feed these the points. Okay, that's what's missing, and this is what we need to feed here. And we're gonna do it by surface closest point because we need UV point. What's different about the UV point is that they all are from 0 to 1 essentially, yeah. And the surface would be our big surface because, so like we are interested essentially in this surface here, right? For the for the result on image sampler. Okay, I will also wire display hidden. It's just like it's super important to keep your script really organized and tidy, and this is one of the things that like literally everyone don't care about, and like literally everyone struggle, although it's not that difficult, right? It's just a matter of discipline maybe. And anyways, so for example, you see the points panel to check what's going on, and you see these are the coordinates, right? It's x, y, and z coordinate. We work in 2D, that's why our z coordinate is like here is 0, right? Because we don't care. And UV point, Okay, this is where I need to reparameterize. Okay, and here you see, right, that these coordinates, like they are like, here is 0 and here is 1, right? 0, 1. So why it's important? Because it just makes your life easier in a sense that you can fit any kind of image, you can change your surface, right? And every time it will work fine, right? It's not going to be dependent on, like, if you change size, the whole script breaks. No one wants that. Okay, cool. So this is UV point, and this is what we're going to fit into our image sampler, right? And here you see it analyzed and give you results from 0 to 1, yeah? I actually don't remember what 0 and 1 means. It's either 0 is black and 1 is white, or other way around. Like, it's quite simple to just, you know, try and see, because you will quickly see it. Okay. All right, let's group it and call it image sampler. Image sampler. Okay. Okay, we need to be faster because I have a lot of stuff to do. Okay. All right. Now we need to choose the points that we need and points we don't need, right? And we will do it through the gate. Like, yeah, in a sense, like, for example, we only need white or like close to white, right? Okay, and for that, we will use larger than. Boom, boom. Okay. We need gate, which is here. Okay, it's actually called stream filter. Anyways. All right. So we will back engineer it, right, together. This is how, like, yeah, this is how you do everything parametrically. We need percentage, yeah, which is like from 0 to 100. Great. We have our percentage gate, we call it. Nice. Let's say this is like in the middle. What we need to do now is we need to remap these values. Yeah, so the percentage is from 0 to 100, but we need from 0 to 1, right? Remember what I said about the intensity, right? It's from 0 to 1. And we do it with remap. This is actually super important component, so you really want to understand what's doing. It's usually 0 to 1, so we construct domain from 0, this is what usually is there, to 100. Yeah. So, and our target is 0 to 1. So, great. This is something that we can change. Okay. Let's do it like this. So same here for 2-hour density stuff. Okay, noise. We remap this number, great. And now we need to understand if this is bigger than that, and if yes, then we use it, right? Okay, and actually we want another gate. We want a gate which would be, we will put it through value list, because for some images maybe you want white, and for some images maybe you want black, right? We call light is 0 and dark is 1. Cool. And let's add it to group. So okay, this will be our gate, and just out of trying, we need to understand what is what. Okay, we use call pattern, right, to actually use this set of, because like if you check it, it's essentially set of true false, right? So it's called a pattern. And to use it, we need our points. Points. Our points are here. Yes. Let's wire display hidden. And also always check that the data structure, it looks the same, right? Okay, it's the same to me. And okay, it worked, but I want this to be more visible. Okay, so light. Yes, we are right. It's light. And if it's dark, it's nothing because we need to feed something to here, right? And here, like if you have invert boolean, this is what you can use, but I think it comes from some plugin, the one I forgot. And so we just need to put smaller than. Yeah, and literally same thing. And connect it here. So now when we change it, we can, right, choose between this. And we can also control how much we need. All right, sounds nice. We call it, I don't know, I mean like cal points. All right, saving and going further. Okay, this is the most, oh yeah, actually this was pretty tricky. This like the trickiest part of the tutorial, although it is quite beginner friendly still, I think, especially if you don't overthink like the most difficult parts of it. All right. Okay, now what we're gonna do is like we're gonna put transformations, which is a pretty powerful thing, right? In general. Okay. Let's do that. We will base our transformations based on an attractor. Attractor is a point or a curve or whatever that changes, like enables you to quickly change the result, right? That you want. And this whole setup is about creating thousands of options in several clicks, right? Okay, maybe thousands is too much, but like still it's just like playing in a very fast pace. Yeah. That's why we need a lot of parameters, then they need to be easily changeable. Okay. Where are we gonna start? Let's create this point. And we created parametrically also, obviously. We need a surface. The surface that is like our overall surface, which is not panels. Actually, you can just copy this guy. Bye. Okay. And we will divide it. Point on surface, it's called. No. Okay, parameter point on surface. This is what we need. Okay, because you see, like we have a surface which we reparameterize, so it becomes 0 to 1, same what we just did here, like earlier. And then we have, for example, let's Control A preview off for now. So if you have a surface here, now you have 0, 0.5, and 0.5, which is always be the center, right, of the surface. But we want this to be kind of like easily changeable. Okay, so let's create a slider from 0 to 1, 0, 0, 0. Okay, and copy it. So here, now through this we can control, right, where our point is located on a surface. Okay, this is the point. By the way, you can also just like get it from Rhino if you feel like it. That's also fine. Okay, we group it. Put it like this blob, lavender outline. All right. Let's move it a little And fine. So now the first transformation we're gonna do is we're gonna scale it and then we're gonna rotate it, right? So let's introduce scale as a transformation. And we want to remap the distance between those points, right? Let's actually bring them here. Points. So like essentially what we're curious about is that, well, let's call it attractor. What is the distance between these points and others, right? And based on that, we will define how much we want to scale the whole thing. Yeah. Okay. And actually, okay, let's use but instead of points, we will scale panels because it's a little bit better and I think it's also faster. Okay, and we also learn transformations, which is the goal, or one of the goals at least. Okay, we bring the panels here, which are those guys, and that will be our geometry to operate with. Yeah, each panel has a center point, which you can make it through like this component area. It calculates the central point. Yeah. And for example, if we don't change parameter like the scaling factor based on attractor, right, which is our plan to do, it all just scales it like half, so it looks like this, right? Okay. What do we need to do? We need to calculate the distance between, yeah, okay, these points and the attractor to have it as well, something we can actually use. All right, this is the distance. Great. Okay, and now we need to remap these numbers. Yeah, so the distance would be the number. Then we will have bounds as our source domain. So bounds is, it analyzes all these numbers and it tells, okay, the smallest one is, for example, here is 44 and the largest is 176. Yeah, so we feed it to source. And then we have target. Target domain is what we need. And what we need is a scaling factor, which I remind you, like 0 is, we scale it, I think like so little that it's like nothing. And 1 is the size it was, and 2 is twice bigger. Yeah, that's how it works. Okay, so we need to decide, and we need to essentially construct domain. Construct domain. I would advise to honestly just play around with what you like. Let's say we're gonna be like from 0.5 till 2.3. Yeah. Nice. Okay. Perfect. So we have, let's say it's like this. Yeah. So this scaled stuff we feed here, right? And you see what's happening. So if I move the point, it scales according to it. Okay, nice. Perfect. Like it looks a bit weird, but once you have the points, it might be looking really interesting because they kind of like, like go onto each other and creating this kind of cool moments potentially if you find them. All right. So, and since scaling is not enough, we also can rotate it. We will do it as well. But also remember, like if you just put this to 1 and this to 1, you essentially do nothing, right? So if you just like feel like don't like this component, and you don't want to redo the whole thing, you can just like also kind of like deactivate it if you put the right numbers. Actually, let's group this one like this. Okay, perfect. Now we essentially, yeah, we take this geometry and now we need to rotate it. Pum, 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 pum. Of course, as planes, we need the same thing. Like it automatically creates XY plane, which is good enough for us, right? Since we are like 2D here. Okay. Creates XY planes in these points that we just feed it, which are centroids. All right, now we need the angles, right? It's like literally the same thing as factors. It just operates differently. What I do is that I put degrees because, you know, like, it's so much easier. All right, and we need to do literally the same thing. We need to remap. Actually, you just can copy this. You can copy this. Okay, literally Control Shift because we don't need to measure distance twice. You can just feed the same thing, and also Control Shift here because this is the same, right? So same params. Actually, maybe not, because okay, but this is like a bit of a design decision. Do you want to? No, wait, no, it's gonna be the same because we scale it. Yes. Okay. Yeah. Because like the centroids are all gonna be in the same place. Alrighty. But now our domain should be more based on degrees, right? So we are like maybe going from 0 to 180. And we remove the digits, right? Cool. Add to group. Okay. So this would be our angles. Okay, very messy. Like in my experience, I don't particularly think it elevates. Okay, let's Control Shift it. It elevates it necessarily, but like what could be interesting is either putting like both 90 degrees. Yeah, that could be interesting, and maybe like some kind of like slight change, like so little that you don't necessarily see it, but it creates a bit of like strange effect. I don't know, but because like as soon as you start to go too crazy here, the results are a bit weird. All right, now we merge, but this is the interesting part because what we are like interested in are these guys. These are called transforms, yeah, and we will merge them and we will do compound transformations, right? For that, we will have to graft it and simplify both of them. Why? Because they all are separated, right? So they don't merge all together. They only merge, you know, like the first with the first and so on. So we go here, we have these guys, we compound them, right? So we used to have 2 in each branch, and now we have 1. Super. And we call these transforms. Yeah, transforms. Okay, I will show how we actually gonna use it for our points. Just wait a second. We group it. We group it as transformations. And here we are, like almost there, almost finished with the tutorial. I mean, I think it's not very difficult overall. Now we need to actually use it, yeah? And we do that with a component called transform, not this one. Transform, this one. We need the geometry and we need an object. Yeah, the geometry that we need are our points. Let's bring it here. hidden wires. Okay, so also like check the data structure because it really needs to match. Okay, I think it matches, right? Because we have all these data trees. No, data trees. We have the branches, which is 0, 1, 2, 3, blah, blah, blah. And here is the same, right? So every point in this branch will have this transform, right? Let's see. Like if you mess up the data structure, this is where a lot of confusion starts to happen, I think. Well, I saw. Like, so it's important that you kind of like always check, you see how it looks, because like 99% of cases you can see, yeah, you can see it from here. So if it doesn't match, if they look differently, that means that something is off. Yeah. Okay. Cool. And we group it. We call it transform points. Transform points. All right. And now, final stages. We remove duplicates with, I think it's a kangaroo, but there are like different components like this. It just like double checks that everything looks nice. And we use dot display for, well, I don't know, to make it look nice, yeah, in our screen. We can choose the color. And we can choose the size, which I think can be just like 1, it's fine. Cool. Preview, we call it. Now, Control A, preview off, and only enabling this guy. Yeah, so, I mean, congratulations, we finished. Now what you need to do is just like play around with it and see, yeah, like what kind of interesting stuff you can get out of it. Yeah, like you can also change certain things around if you feel like it, obviously. Yeah, like yeah, like see how changing like a tractor or changing like the transformations or the image or like literally everything at once, yeah, it's gonna like give you very different results, right? Like different patternings. Yeah, okay, I think this is it. So play with it, and to save the points, to transform it, for example, to robotic file, what you need to do is that you need to create a container. For example, iteration 1. Okay, sorry. Data. You say iteration 1. And we connect our points here. And then we internalize data. So now, preview it off. If you change certain stuff here, yeah, it doesn't matter because you kind of like save your result, and you can Control C and open a robotic file and Control V there, right, and connect it. So okay, that's good. I hope that everything is clear, and see you soon. I don't know. Okay, ciao, bye.